All right, Matthew, we've got lesson 1-1, our first real lesson, one-step equations. All right, so we are going to use properties of equality. So properties of equality in math just mean that there are certain rules of math that you're allowed to use to help you solve equations. The first one is the addition or the subtraction property equality. And all these simply say is that it's okay to add the same amount or subtract the same amount from both sides of the equation. So we can add or subtract the same amount to both sides of the equation. So an equation is kind of like a balance that's sitting there. And if you do something to one side of the balance, to balance the whole thing out, you have to do it to the other side as well. So you can add the same amount or you can subtract the same amount. As long as you do it to both sides of the equation, in math, that is perfectly fine. The multiplication and division of property of equality are similar to each other, and they're similar to the addition and subtraction. But what they say is that you can multiply or divide the entire side of an equation by the same amount. So one side of the equation and the other. So you can't pick and choose what you multiply and what you don't multiply. If you multiply one thing by 5, you have to multiply everything on both sides of the equation by 5. Whereas the addition and the subtraction properties of equality, you're going to do a little bit more of combining like terms, where the multiplication and division, the way that they're kind of used wrong a lot is people pick and choose what they multiply or divide by. So we can multiply or divide can't spell today. We can multiply or divide the same number to all terms of both sides of the equation. All right, inverse operations. Inverse operations mean that in math, everything has an operation that undoes it or that cancels it out. And this is called an inverse operation. So we know that adding and subtracting are opposites of each other. Those are inverse operations. So if you see addition and you want to get rid of it, you would subtract by the same amount. Multiplication and division are inverses of it. There are other inverses, but for what we're doing today, we're going to just use these inverses. So if it's a multiplication problem and we want to undo it, we would use the division. All right, so we're going to use these inverses for these operations. Now, when we are doing this, I want you to get into some good habits and to make sure that you're not just going all willy-nilly on this. We're going to draw a line down the equation so that if I do to something to one side of that line, I have to do it to the other side. Now, I know a lot of you are going to just look at that and go, oh, I don't need to do that. I'm great at math. Just do it. Humor me for a little bit just to make sure that you're not making errors and that you're doing something to both sides of the equation. So here I've got x minus 4 equals 12. Now I want to isolate x, meaning get it by itself. Right now, x is being subtracted by 4. So I need to use an inverse operation, the opposite of subtraction, and to get rid of that 4. So the opposite of subtraction is addition. So I'm going to use the addition property equality and do the opposite of subtracting 4. I'm going to add 4 to this side of the equation, and I'm going to add 4 to this side of the equation. So it's balancing out. The addition property equality says I add or subtract the same number to both sides. I added 4 to both sides of this equation. So what does that do? Well, over here, negative 4 plus 4 That's 0. Those 4's are gone on that side of the equation. We get x on that side of the equation. On the other side of the equation, 12 plus 4, we get 16. We have now isolated the variable by using inverse operations. Okay, we come up to our problem. Next one, we are going to use inverse operations again. All right, sorry. I had to go get my dinner real quick. My wife was bringing me dinner. See? Oh, deliciousness. All right, so let's go ahead and finish this so I can eat my dinner. So for the next one, we're using inverse operations. So the inverse of positive 10 adding 10 is subtracting 10. So we're going to use the subtraction property of equality. We're going to subtract the same amount from both sides. So to get rid of positive 10, I'm going to subtract 10 from both sides. So I can see here that 10 minus 10 is 0. Those go away. And I'm left with y. I've isolated y. Then on the other side, negative 3 minus 10. Both of them are negative, so I get negative 13. Next, we are going to keep on doing this. I know you don't want to, but do it anyways because I told you. All right, so we've got subtracting 4. The opposite of subtracting, the inverse operation, is adding. So I'm going to use my addition property of equality. I'm going to add 4 to both sides of the equation. That will cancel out the negative 4. Negative 4 plus 4 is 0. Double check that because a lot of times, like when you're not paying attention, instead of like adding 4 to both sides, you'll subtract 4. And you're like, oh, I'm doing it great. I'm subtracting 4. But then double check, are you really canceling it out? Because you could subtract 4 from both sides. But if you did that, you'd still have b minus 8 over here on this side. So double check what you're doing. Pay attention. It never hurts to do a little double check. So we get b equals negative 13 plus 4. That should be negative 9. All right, we're going to keep moving. Here's a few more of them. 5 plus a. Now, I'm not trying to get rid of the a. I'm trying to get rid of the 5. So for this one, I'm going to subtract 5 using inverse operations. I'm going to use the subtraction property of equality here. Subtract both sides by 5. This will eliminate my 5s over there. 5 minus 5 is 0, so that is eliminating. Just double checking my work as I go. And then negative 14 minus 5, we add the numbers, keep the negative sign, so negative 19. This one here, we've got 32 equals r minus 8. So for this one, it doesn't matter that the r is on this side. I still want to isolate it, meaning move everything away from the r. So I'm just moving to the other direction, which is completely fine. Negative 8, the inverse operation is adding. So I'm going to use the addition property of equality. Adding 8 to both sides. Let's see what happens. The negative 8 did cancel the positive 8. And on this side, I end up with 40 equals r. Now, I like to flip this around when I'm done to write that r equals 40, but they are equivalent. These are the same thing. You could write it both ways. Last one in this section. So I've got t over here. I need to eliminate this negative 23. The inverse operation is addition, so I add 23 using the addition property of equality. Add 23 to both sides. So negative 23 plus 23, yep, those eliminate. I'm left with t on that side. Negative 23 plus 23, those eliminate and they become 0. So my final answer, t equals 0. All right, now we're going to still use inverse operations, but we're going to use the multiplication and division properties of equality to isolate the variable. So same process. This is 3 times x. So what is the inverse of multiplication? Division is. So I'm going to use my division property of equality. I'm going to divide both sides by 3. Now, when you divide by 3, you're not getting 0 like you were in the addition property and the subtraction property of equality. You're making a 1. So that's becoming 1 over there. So 1x, or just x, And then over here, 3 goes into 45 15 times, and it's negative because it's a negative divided by a positive. So negative 15 is our answer. Next, we're going to draw the line because we're good people. Okay, so negative 5 times y. We're not going to add 5 to both sides because the operation is not subtraction. The operation here is multiplying. We are multiplying by negative 5, so the inverse operation would be to divide by negative 5. All right, so negative 5 divided by negative 5, that becomes 1. So we get y on this side. And negative 65 divided by negative 5, that's going to be a positive answer. And then 5 goes into 65, 13 times. Moving along. Next one. 14b, that means 14 times b. I need to get rid of that 14 so that b can be isolated. So I'm going to use the division property of equality. The inverse of multiplication is division. I divide both sides by 14. Now, my answer is not 2. Because see how the top, the numerator, is bigger than the denominator? That means I'm going to get a fraction answer on this one. So I've got 7 over 14. And we always look to reduce. Is there any number that goes into 7 and 14? Yeah, 7 goes into both of those. 7 goes into 7 one time. 7 goes into 14 2 times. So our final answer is that b equals 1/2. Moving on. We're going to draw our line because we're good people. Now this is c divided by 2. So the inverse operation would be multiplication. I'm going to use my multiplication property of equality and multiply both sides by 2. So 2 divided by 2 is 1. So all I'm left with is c on this side of the equation. On the other side, 2 times negative 15 is negative 30. Keep on doing it. All right, so this is negative a over 3. Now, if I just multiply by 3, I still have a negative over there with the a. So instead of just multiplying by 3, I'm going to multiply both sides by negative 3. Because negative 3 divided by negative 3 is positive 1. So over here, we get a, because negative 3 divided by negative 3 over here. And then 12 times negative 3 is negative 36. Last one, remember when we were doing fractions in the unit 0? If you got 1 on top, and then t over here is the same thing as saying t over 4. Remember, this is just multiplying by 1 and dividing by 4. So I don't need to undo multiplication of 1. I just need to undo division of 4. So I'm going to multiply both sides by negative 4. Oops, forgot my line. All right, so negative 4 divided by negative 4, that becomes 1. And so I'm left with t equals negative 6 times negative 4 is positive 24. All right, last thing. What if you've got a fraction like this one, but we have a number other than 1 in the numerator? What we're going to do for this is use what's called the multiplicative inverse. Now this is saying multiply by 2, divide by 3. So if I wanted to undo it, I could do it in 2 steps. But we're doing 1-step equations. So the way to undo multiplying by 2/3 in 1 step is to multiply by the inverse. The inverse is when we switch the numerator and the denominator. Oops, 2. So see how I've switched the numerator and the denominator? Now watch what happens when I multiply. 3 times 2, 6. 2 times 3, 6. 6 over 6 is 1. So those did go away. So I get x equals, now if I do it to one side, I have to do it to the other side. Remember what we said about fractions. The numerator we're multiplying by, the denominator we're dividing by. Now, a lot of times, I've told you in the past, we can multiply 6 times 3 and get 18, and then divide by 2. And that is one way to do this. But I do want to show you this. 18 divided by 2 is 9. I do want to show you this. Sometimes it's better to divide first, especially if we see that 2 goes into 6, and it does. So it might be better on this problem to say, okay, 2 goes into 6 3 times, and then we still have this 3 out there, right? So I divided by 2 first and got 3, and then times the 3 on top, and we still get x is equal to 9. So on this one, I multiplied by 3 first and then divided by 2. On this one, I divided by 2 first and then multiplied by 3. Now, I'm only going to want to do this when I see that the 2 goes into 6. If it doesn't go into 6, I'm going to end up with a fraction, and it's probably not a good idea to do it. But it works kind of nice if you do that. All right, we only got 2 more. Last problems. So this one, the multiplicative inverse would be negative 5 over 2. So I'm going to multiply both sides by negative 5 over 2. Okay, so I'm going to multiply by negative 5. I get y equals negative 10 times negative 5 is 50. And then I'm going to divide by 2. 50 divided by 2 is 25. Now remember, I said you could do the other order. So if I divide by 2 first, I could have gotten instead y is equal to negative 10 divided by 2 is negative 5. And then we're going to multiply by that negative 5 that's still there. Negative 5 times negative 5 is 25. I'm getting the same answer. I divided by 2 and got negative 5, and then I multiplied by negative 5 and got 25. Either way works. Last one. We're going to do our little line to make sure we're doing the same thing to both sides of the equation. The multiplicative inverse on this one would be negative 2 over 3. Okay, so multiply first. 3 times negative 2. Oh, that's an H, not a, you know what I'm talking about. H equals 30 times negative 2 is negative 60 over 3. And 3 goes into 60 negative 20 times. Or if we divide first, 30 divided by 3 is 10. And then 10 times negative 2 is negative 20. We still got the same answer, so we can do it in either order. That's all the math I got for you today. Until our next lesson, I will see you in Math Hard. Bye-bye.